That's a really hard question because EEs do so many different things. Even at a company like TI, we have people that are involved in the semiconductor process, so actually making the materials, to the packaging, to testing, to how the products work in application. But really at the core of it, it's about providing a foundation for all of the technology that you see in the world today.
An electrical engineer deals with electricity, believe it or not. And that is the most specific definition I can give, because electrical engineers can be working on circuit design. They can be working on software, usually software that's a little lower level, interacting with hardware. They can be working on algorithms. Anything that you own that runs on electricity was designed by an electrical engineer.
Every electrical engineer you'll meet in your life will have a different role and a different opportunity. But to me, electrical engineering is a way to utilize the electricity and the technology around us and apply it in a hands-on, realistic application.
So I took the class Engineering and Beyond, which is a survey of all the different departments. And two things really stood out to me. The first was that they said electrical engineering was the most math intensive, which is something that I was really interested in. And then also there was one presenter who talked about how at the end of his electrical engineering degree, he really understood how a computer worked from top to bottom, not just how to use it, but how it really worked.
I was interested in both electrical and mechanical engineering. I decided to go with electrical because I liked the amount of applications that I could do with an electrical engineering degree. I liked all the options that electrical engineering provided.
So I started out undecided at SMU, but electrical engineering really intrigued me because of my love for technology and learning about what's going to happen and what's new and all the exciting things that will happen in the future.
Basically, we make the integrated circuits that go in all of the computers and electronics that go into space. So on satellites, rockets, space shuttles, you name it, everything. Which is really cool because we get to be a part of this next wave of human exploration. It's a really exciting time to be in this field, and really none of it would be able to work without the parts that we're making here at TI.
I work in a lot of industrial applications, a lot of automotive applications. So how do you get your car infotainment system working properly? How do you get one big robot that's putting together car pieces to talk to another? And I get to write the software that figures out how everything communicates with each other.
So my favorite part about being an electrical engineer at Texas Instruments is working on product definition for our customers, whether it's with medical devices, consumer products, or space products, which is really cool. We get to see a whole different types of aspects within TI.
So as an electrical engineer, I'm involved in testing these integrated circuits that go into these spacecraft. And it's really, really important because once you send something off into space, it's not like you can send them back to us and have us fix them. So it's really important that we get them right the first time, which really introduces a lot of interesting tests that we have to put these through.
Well, I'm a Linux applications engineer, and that means I work with our processors. On the top side, up here where the user interacts with, you'll have your applications running, and on the bottom side, you've got the hardware. And I'm working on all the software in between. So let's say you're in a car, you want to turn on the AC. You go to the infotainment center in the middle of your car and you push the increase air button. That sends a message down into the operating system. That's where the code that I'm dealing with. We would go down, we'd move some motors to make the fans run higher, and then it would go back up into the user space application to tell you, hey, we've made your AC a little bit colder for you.
So when the wafers leave the fab, I work with the assembly and test sites overseas to ensure that our quality is up to par, that we test the parts properly, as well as ensure that the customers are testing the parts and utilizing the parts in the correct way.